Hi, my name's Dave. Today I'm going to show you 5 simple steps on how to master calculus optimization problems. And we're going to go for an example, and I'll show you how to do the steps. So the question we have is, we have a rectangle that's 28 square meters, so we just got to find out what's the smallest possible area for that rectangle. So this is a diagram for the rectangle. We know the area is 28. We have the area and the perimeter equations, and then we sub in 28 for area. Next step is we got to solve for the length in terms of the width. So we just want to make sure we only have one variable in the perimeter equation. So we sub this in back into the perimeter equation. So then we have the perimeter is equal to 56 divided by w plus 2w. And then we simplify it further. And then the next step is we have to derive the perimeter. So in order to figure out what's the width, that helps to minimize the perimeter. We basically have to find the first derivative of the perimeter and set it to 0. So we do the derivative using the power rule. So this is what we end up with for p prime, or the first derivative. So we simplified the p prime a little bit further, and then we set it to 0, and we solve for w. So doing that, we get w is equal to 5.29. Now, when the derivative is 0, we can have a maximum as well as a minimum. So the next step is we want to actually check, right, if the width that we got here is actually the width that will give us a minimum for the perimeter. So to do this, what we got to do is we have to plug in a number that's less than 5.29 for the width into the equation for p prime, and then we got to repeat the step except with a number that's bigger than 5.29. And we want to see if p prime is positive or negative. So we put in a number that's less than 5.29. We know that p prime is negative, so that means if the width is less than 5.29, the slope of the perimeter equation, it's actually negative. And then when the width is bigger than 5.29, we know that p prime is positive. So that means when the width is bigger than 5.29, the slope of the perimeter equation is actually positive. So we put those two pieces of information together. We know that the slope of, or the equation for the perimeter, it actually goes down and then it goes up when the width hits 5.29. So we know that when w is equal to 5.29, we actually have a minimum. So in order to actually calculate the minimum perimeter, we just plug in w equals 5.29 back into the perimeter equation. So doing that, we get the perimeter is equal to 21.17, and that's our final answer. So just a quick summary on how to answer these kind of problems. We want to draw the diagram, and then we set up the equations and substitute so that the equation we derive, it only has one variable. And then we set the first derivative to 0, and then we solve for a variable. We want to confirm if it's a max or a min like we just did. And then at the end, we just plug the variable back into the original equation to solve for the actual max or the min. So that's it for this video. Hope you found it helpful. Please hit subscribe. It'll help out the channel a lot. And if you want to let me know in the comment below what you want me to go over, that'll be really helpful. Thanks for watching.